good.
Right. So this is the thin spherical lenses lab. As you can see, we have our incandescent light source here. We've got a yellow filter. And on the back side of it, we have a crossed arrow little target so we can see a symbol. And we're setting that to 0 on our track. And we typically just leave it there. This part is for the unknown lens, so we're trying to figure out the thickness of it.
A couple other lenses we were working with, 48 millimeter. This is for the -22, and then this guy over here is 127.
All right, and this guy, just our target, so we can see when our image appears. So for this, we're going to start off by setting L equal to 300 and see where we get an image.
L being the distance between the light source, between the arrow and the screen in which the image is being displayed.
All right, so now we slide our lens until we can get an image, and you'll be able to see it in 1 second. We should get a sharp image, so you start off, go until you get the sharpest, and then that's where you would take your measurement for the left side of D.
This measurement would then be the distance between the arrow and where the lens is currently.
Alright, and now if we turn the lights off one more time, you can slide and we can see where we find the second image, which you guys may not be able to see. The lens might actually be in the way, but it's the same idea as the first part. And it's a really, really small image.
Where's the camera?
But that's where we take that's it. Whatever.
Yeah, that little dot on there is the image. It's kind of hard to see on the camera, but it's there. And so at that point, we're going to go ahead and take our measurement for our second position of the lens. And from those two measurements, along with the L, the distance between the arrow and the screen, we can calculate D, which is the distance between the two positions of our lens. And using all those, we're able to calculate focal length.
Probably.
So after steps 1 through 4, where we measured the focal lengths of some positive lenses, it asks us to measure the focal length of a -22 millimeter lens for step 5. So the procedure starts pretty much the same with an object right here that has the yellow filter on one side and the arrow object on the other. We're going to place that again at 0. Then it asks us to take one of our known focal length lenses, one of our positive ones. In this case, we chose 127. We got the most accuracy out of that one as well. It was easiest to work with. So we place that right about 250 millimeters, and then we're going to go ahead and find an image.
All right, once we find our image, we record this length because that is going to be where the virtual image is located after we put our negative lens in. But before we put the negative lens in, we have to move our target back 10 to 20 millimeters. We chose to do 20 just to give ourselves a little bit more room, and it worked out for us. So then we have our negative lens, and you want to place it on the side of the holder that has less of this bulk here so we can get closer to the target if we need to. We place it on there, and we find our first image somewhere right about there. After we find our first image, we record that number, and then we're asked to flip the lens and put it on the opposite side of the holder and find our focused image there. We record that, that position, and then the position that is halfway between the two positions for the negative focal length mirror is where the mirror is actually located.
Using these measurements that we took in this step, we can go ahead and calculate the focal length of the lens, make sure that it matches the value. We can assume the virtual image, like Ricky said, was at the initial image spot, and complete the rest of the lab.
Fair enough.